Okay, in this video we are going to be looking into programming the ARM microcontroller, and we'll be using the ST Microelectronics ARM microcontrollers, which you can see here on the discovery board. Now this is a Cortex M4 microcontroller. It's STM32 F407. Now there's another ARM microcontroller made by ST Microelectronics. It's on the Blue Pill module, which is a pretty popular module. Now this is a Cortex M3 microcontroller. It's the STM32 F103. Now both of these microcontrollers have an onboard CRC generator. So if you're involved with sending data from point A to point B, you want to be able to send a CRC checksum along with that data. Now if you're involved with building a radio link using an HC06 Bluetooth module, or maybe a LoRa module, they have their own built-in CRC generators, so when they send data, they send a CRC checksum along with the data. But if you're using an inexpensive OOK on-off keying radio link, then by adding some software and adding some CRC checks, you can make your link a lot more reliable.
Okay, here's the ST Microelectronics datasheet on the CRC calculation unit. Now this is built into the microcontroller, so it saves us writing a lot of code. Now if we move down to the CRC main features, you can see the polynomial that it's using. That's it right here. That's a generator polynomial. And if we take out all the coefficients, if we bring down all the coefficients, we'll get a hex number of 4C11DB7. So we have to remember that. That's the polynomial that we'll be using in our calculation. Now if we go down to the block diagram, so it has a data register. So we input our 4 bytes, it's the 32 bits, into the data register. Then it will calculate a CRC checksum, and then we read that in the data register output. So this data register up here and this data register is the same address. So we just write to it. It will calculate the CRC checksum, and then we read the same register, and it will get the CRC checksum. So next we're going to go online to a CRC calculator, and we'll do some calculations, and then we could compare it to the CRC checksum when we write our code. Okay, this is our online CRC calculator, and if you look down to CRC-32 MPEG-2, that's the one we're going to be using, because if you look over at the polynomial, that's the one we saw on the data sheet right there. So we can enter some data. We'll enter 4 bytes. We'll make it easy. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2 is 1 byte, 3, 4 is 2 bytes, 5, 6, 7, 8. So those are 4 bytes. And we'll do calculate CRC. And if you look down, there's our checksum. DF 8A, 8A, 2B. So we have to remember that. So we'll do another one. I'll erase the input, and I'll put in 1, 1, 2, 2, 3, 3, 4, 4. And we'll do a checksum. If we look down, there's our CRC checksum for those hex, for those 4 bytes, B14257CC. So you just remember those two, and then when we do our calculation on the ARM microcontroller, we'll see if it matches these CRC checksums. Okay, next we have to look at the data sheet and see where the CRC generator lives in memory and what bus it is on. So if we look down, there it is here, CRC, and this is the base address, so we have to remember that, because in the data sheet it only gives you the offset. So this is the base address of the CRC generator. It's 4002 3000, and it lives on the bus AHB1. That's the Advanced High Performance Bus 1. Now second, we have to look at the RCC. That's a reset and clock control, because when you power up an ARM microcontroller, all the peripherals are shut off to save power. So we have to turn on the CRC generator because it will be powered off. So we have to look in the RCC register, and the base address is 4002 3800. So we'll have to remember that. So we're looking at AHB1 bus, and we're looking at 4002 3800 for the RCC to turn on the CRC register, and the actual CRC register is at 4002 3000. So with this information now, we could start writing code so we can get our CRC generator up and running. Okay, back to the data sheet. So now we have to find the RCC register for our CRC generator, because when you power up an ARM microcontroller, all the clocks to the peripherals are disabled, so they're powered down. So if you look down on this list, we see RCC-AHB1. See it right here. That's what we're looking for. And it ends in ENR. That means enable register. So we'll go there. So there it is there. And if you look at the address offset, it's address offset hex 30. So our base address was 4002.3800. So the address of this register is 4002.3830. Now this register is like a breaker box in your house, your electrical breaker box. It's usually in your basement. You go down there and you could turn on different circuits. You could power different circuits in your house. So this is the breaker box of the microcontroller. So we have to find the CRC breaker and turn it on. And if you look over here, see it says CRC enable. That's bit 12. So we have to flip bit 12 high. Now that will turn on the power to our CRC generator. Okay, here's our CRC data register. This is where we write our 4 data bytes into. And the address offset is 00. So the address of this register is 4002.3000. Now the reset value of this register is all F's. So we have to do that before we start a calculation. So we write our 4 bytes into this register. Then we read the register. And that will be our CRC checksum. Then we have to reset the register to all FFs. So if we go down to the control register, CRC control register, and the address offset is 08, so that would be address 4002.3008. And if you look at bit 0, that's the reset bit, so we set that high, and that will reset our CRC data register to all Fs, ready for the next calculation. Okay, I have TerraTerm up and running my computer, and it's connected to the serial port of my microcontroller. And I'm running Forth programming language on my microcontroller. So we could upload a program, a KISS program, keep it simple. So we'll be direct register programming in assembler and Forth, and it will be interactive. So I'll load some code where we could exercise the CRC generator. You can see it loading. If you look at the very top, the first word is crc.enable. And if I type that at the OK prompt, it will actually run bit 12 at that address set. So it will set bit 12 at that address. That's the RCC register. So that will actually power up the CRC generator. That's our little breaker. It'll turn on the CRC generator. So if I actually look at that register, we can look at bit 12. And right now it will be off. So we'll have a look at it. So we start from the very right, that's bit 0. And if you go over to bit 12, you can see it's 0. So it's off. So if I run CRC enable, that will set that bit. So I'll run that. Now we'll have a look at that address again. Now you can see bit 12 is on. So now we just turned on the CRC generator. We gave it power. Now CRC reset will set the CRC register to all Fs. So if I run that, now if we look at the register, it's all Fs. So now with those words, CRC will write to the CRC register, and question mark CRC will read from the CRC register. So we'll enter in some data. So go 1, 2, 3, 4, 5, 6, 7, 8. Go CRC. Now we go question mark CRC. Now I'll read it. And there's our CRC checksum DF8A 8A2B. Now if we put in some more data, 1, 1, 2, 2, 3, 3, 4, 4 CRC. Now we look at the CRC checksum. It's B14257CC. And you could check those checksums to our online calculator that we did before in the video, and you'll see that they match. So with those words there, the CRC enable turns it on, CRC reset will reset it for the next calculation. Then CRC writes it to the register, and question mark CRC reads the CRC checksum. So that's all the words we need to exercise our CRC generator using KISS. Keep it simple. So that was a little example how we could do direct register programming with the STM32 microcontroller. Okay, that was my little primer on how to run a KISS Keep It Simple program on the ARM microcontroller.
using assembler and Forth. So when you get very familiar with the internal registers and buses of the ARM microcontroller, you could write your own direct register programming code and then assign that code to a Forth word. And you could build up your own high-level language. That's why NASA uses Forth in their space probes. Now I've actually written my own language called Next, N-E-X-X, to control Kenwood's NXDN digital radios, and that was featured in Cellar magazine. Okay, here's the Cellar magazine. It's an electronic magazine where I wrote my article. It's called Long Distance Wireless Radio Control. And inside, you can see a 5-watt portable can control a bank of relays to turn them either on or off. That sends a signal digitally over to a mobile radio. And on the back of the mobile radio there's a DB25 which controls the relays. And there's actually an RS-232 port there where you could send in data using my Next programming language, which is written in Forth. So if you have any interesting projects, you could send them into the editor of Cellar, and if they like it, they'll print it. And you can get paid. You'll get paid for your article. So you never know, you might become a full-time author.